Unit rate and unit price are very important math skills to have in our daily lives because they help us solve important problems that we face all the time. Let's look at two of them, one involving speed, which is a unit rate, and one involving unit price or unit cost. Let's look at the first problem. Anna drives 280 miles in 4 hours. How long will it take her to drive 350 miles if she continues at the same average speed? And when we plan a trip, a lot of the time, we need to know things like this. So let's see. Anna drives 280 miles in 4 hours. That's important. And what do we want to know? We want to know how long will it take her to drive 350 miles at the same speed. So, again, we can use a ratio table or we can set up a proportion. So, let's do a ratio table first. And what are we comparing? We're comparing miles to hours. Okay, and what do we know? We know she goes 280 miles in 4 hours. And usually in a ratio table, we're looking for relationships based on multiplicative reasoning, which is common factors or greatest common factors, and multiples, common multiples. So let's take a look. We're looking for a relationship between 280 miles and 350 miles because that's the information we have. And unfortunately, I don't see a relationship between 280 and 350. So what I'm going to have to do is I am going to have to do our default reasoning, which is to find the unit rate or the average speed in miles per hour. And again, per would be in 1 hour. And so what do I have to do? I make my little Amazon arrow. And I have to divide. 4 divided by 4 is 1. And I have to do the same thing up here. And I have to divide by 4. And 280 divided by 4 I know is 70. Because I know that 28 divided by 4 would give me 7. Well, now if we take a look, I can see a relationship between 70 and 350, and if I multiply 70 times 5, I will get 350, and so I have to do the same thing down here to get 5 hours, and you see she will need to drive 5 hours. Whoops. She will drive 5 hours at her average speed or unit rate. And you might be able to see that the importance here of unit rate is we can't get directly from 280 miles in 4 hours to 350 miles in 5 hours. So we need that middle step of finding our unit rate or our average speed. Now, if we wanted to use a proportion, it would basically be the same thing. We have 280 miles in 4 hours equals how many miles in 1 hour? And again, we're going to be doing the same operations. So it's going to look pretty much the same, right? And the way that I like to think about it, and this is why I like to do a horizontal ratio table. Hold on, let's see. We have we have 350 miles. Okay, and again, this is times 5. So times 5 would be 5 hours. And if you look closely, you can see that even though it's presented as a proportion instead of a ratio table, I could kind of do this. Look at what I can do. If I did this, right, it pretty much looks exactly like our ratio table. So it's the same exact thinking. Some of us are more comfortable with a ratio table and some of us are more comfortable with a proportion. And either way, the answer to the question, how long will it take her, is it will take her 5 hours. And that's one way that we use unit rate. In this case, again, speed is just a unit rate. Now, let's look at another very common use, and that is going to the grocery store. And especially around Thanksgiving time or Christmas time, any kind of holiday, when you want to go to the grocery store because you're making a big meal, you want to spend as little money as possible. And finding out which is a better buy is important for your budget. So let's see. Now, this is a slightly different problem. So let's look at what we have here. Okay, which is a better buy? We are comparing an 18-ounce jar of grape jelly to a 40-ounce jar of strawberry jam. Okay, and the strawberry jam is going to cost $9.60, and the jelly is going to cost $4.68. And so you might look at this and say, wow, $4.68 is a lot less money than $9.60, so that would be the better buy. But if you look closely, you're getting less while you're paying less. Which is better? I don't know. We have to figure that out. Now, here's the thing that you have to be mindful of. And there's a reason that I highlighted the grape jelly and the strawberry jam. Normally it doesn't matter, okay? But here we are talking about two different rates or two different prices, right? And so we have to have two different proportions or two different ratio tables, because you cannot set up a proportion with different ratios. You cannot set up a ratio table with different ratios. The whole idea is that they are equivalent ratios. So here's our strawberry jam. Okay, so now what will we do? First, let's do a ratio table. 18 ounces. Okay, so what are we comparing? We're comparing ounces to money. Okay, and we get 18 ounces for $4.68. Now, here's another reason that I like a ratio table, because in this ratio table, I have to go back to the problem, and if I say to myself, what do I want to know? I want to know how much 1 ounce costs, right? Because that's what I'm going to compare to the strawberry jam. I have to know what 1 ounce is. I don't want to know how much grape jelly I can buy for $1. So we have to know where to place that 1, okay? It's how much money per ounce. So it doesn't matter if I put ounces up on top or on the bottom, as long as I know that it's per ounce for 1 ounce. What do I have to do here? Divide by 18. And here comes the hard part with unit price. I have to do division. All right, so I'm going to do some long division. It'll be a little bit of a review. I have to divide $4.68 by 18 ounces. Now, the first thing I want to do, pop my decimal point up on top, and then I go through my long division. Does 18 go into 4? No. So I'm going to put a 0 up on top of the 4. Every digit in my dividend needs to have a digit above it in the quotient. Okay? So now I have 18 goes into 46 how many times? Well, I don't know, but I know that 2 times 18 is 36. So let me put a 2, and that would be 36. And I'm going to subtract. Well, 18 doesn't go into 10, so I'm going to have to bring down the 8. Now, how many times does 18 go into 108? Well, let me think about that. I know that 9 times 12 is 108. And if 18 is twice as much as 9, it goes in half as many times. So if 9 times 12 is 108, 18 times 6 is 108. And let's make sure. 6 8s are 48. And 6 and 4 are 10. And here we go. And so we have 26 cents per ounce. Okay, now let's do our strawberry jam using fractions so that we get both of these covered. Okay, so for the fraction, we have to have the ounces in the denominator because we want per ounce, so we want our denominator to be 1. Okay, so what do we have? We have $9.60 for 40 ounces, and we want to set up the proportion, ounces, and we want for 1 ounce. Okay, and my Amazon arrow, I have to divide by 40, and same thing up here, divide by 40. Here we go, long division again. 960 divided by 40. Okay, pop the decimal point up here. Okay, 40 does not go into 9. How many times does 40 go into 96? Well, 40 times 2 would be 80. Okay, and let's do this. 6 minus 0 is 6. 9 minus 8 is 1. 40 doesn't go into 16, so let me bring down that 0. How many times does 40 go into 16? Well, again, I'm going to use my number sense. I know that 4 goes into 16 4 times, so 40 should go into 160 4 times. Let's make sure. 4 times 0 is 0. 4 times 4 is 16, and we're left with a 0 remainder. So this is going to be 24 cents per ounce. So let's take a look at what we have. We have the grape jelly is 26 cents per ounce, and the strawberry jam is 24 cents per ounce. And so you can see that only by comparing per ounce or comparing the unit price do we know that the strawberry jam is actually a better buy. That is, unless you prefer grape jelly and then you want to spend the extra 2 cents. So again, the math alone is not going to tell us which to buy. Okay, we have to look at that and we say, well, here's the math. 26 cents per ounce versus 24 cents per ounce, and I use that math to make my decision. And that's how we use unit rate in our daily lives.